This video walks through the Gravity Engine 2 scenes in the Tutorials Going Further folder. The idea is just to do a quick look at each of the scenes so that you know what they're about and can decide which ones you want to look at in more detail. So we'll just get right to it with ship multiple maneuvers. There is a whole separate video that describes this in more detail, but the point here is that we can do kind of very classic space gamey thing where we chain together a bunch of maneuvers. We can add another maneuver point. We can say, let's put that maneuver point at apoapsis. We can add another maneuver. We can even tilt it a little bit, which you can see here. And then we can go ahead and do those maneuvers. Very handy if you want to learn some things about how to chain together a sequence of manual maneuvers in Gravity Engine 2. There is also a facility in Gravity Engine 2 to do look-ahead trajectories. Now, this is a different thing than displaying an orbit. Displaying an orbit is a deterministic thing. It's a two-body thing. Here we very specifically have two fixed stars. It's not very physical, but it actually turns out to be something Euler looked at. It's called the Euler problem. And then we have some bodies that are going to move in the gravitational field of these two fixed bodies. So there's no orbit we can plot, but what we can do is we can look ahead by doing a trajectory, by looking at the future path. And that's done in the GS body, I beg your pardon, in the GS display body under this trajectory block. And a check mark here, show trajectory. And then you have to provide a line renderer. So when we go ahead and play this, as you would expect, you see the projected future path of each of these bodies. If you update, like make a maneuver in one of these bodies, then those trajectories will get recomputed. The third example is just a collider sanity scene. It shows you how if you have for example, a satellite here and also on the planet, you can add a GS collider component, which is described in more detail in the text. In this case, I've set it up to be a bounce. And then as you would expect, as the planet comes into the sphere, we're aware of the radius of the sphere, and we're going to bounce and adjust the physics velocities in the core engine. And you can set the bounce factor as you go. You can also change it to absorb the body if that's what you want to have happen. External forces demonstrates different ways in which you can add or change the acceleration that's happening to bodies in the internals of Gravity Engine. For example, if you want to add a little bit of ion drive thrust in the direction you're traveling, then you can do that by adding a component, and the result is the orbit spirals outwards. And you can see here I've got a trajectory running, so you can see the future path the ship is going to take, and you can see the orbit that's predicted at each point is based on its current position and velocity. And the way that happens is if we look at the ship, we have an ion drive external acceleration script added to it here. This gives you the acceleration value and the start and the end. If you want to change the force between bodies, ion drive just applies to the ship itself, but you might want to actually change gravity itself and say, what if gravity were 1 over r? So we'll go to that scene. And then if we hit play here, what we have is a ship and some particles in 1 over r. We'll just speed things up a little bit. So gravity, 1 over r squared, is unique in that it's one of only two forces in which orbits close in on themselves. And in this case, when we use 1 over r, we don't get orbits that close in on themselves. We get sort of spirograph patterns. There's an additional demo that shows the effect of a non-round Earth, which is a GE2 force. I'll let you have a look at that on your own. Another way to drive the evolution of bodies is through a table of values, which is sometimes called an ephemeris. So in here we have two ships, and we have set the GS bodies to ephemeris mode, and then we have provided a resource file that is just a table of values versus time for how these ships move. So now you can make things move more or less however you want. So in this case, I opted to do triangles. And here again, I'm using a trajectory to show you the future path of these ships. So they're going to go, this one's showing its trajectory, this one's showing its trajectory. One of the things that gets talked about in the documentation, and there's a fairly extensive discussion of what's going on, is the fact that in orbital mechanics, orbits are in the XY plane and Z is up. That's a right-handed coordinate system. In Unity, it's a left-handed coordinate system. So the easiest way to manage this is in the display controller to enable this XZ orbital plane. And then in the display configuration, the orbit will look like it's in the XZ plane. Internally in the physics engine, it's really in the XY plane. This just affects the way we display things. So we can go ahead and play this. And the point here is you can see that when we use the XZ plane, we get the kind of orbit we expect with a positive inclination and an ascending node here. And when we use the XY plane without the XZ checkbox, and orient the camera appropriately. So we're looking down on the XY plane, the Z goes down, and the orbit is got the descending node here, which is not going to be what you would see, for example, in an orbital mechanics book. The other thing that's useful here is you have two different display components looking at the same bodies. So where there's only one GS controller GE core instance moving the bodies, and we have two different views of them based on the two different display components. The final scene, called record output, is a little more technical. There's not much going on in this scene at all. And if you look at it, the main script is this record controller. What it's going to do is create a GE core, so we're not using a GS controller, we're just going to do our own little physics modeling behind the scenes, and then it's going to go ahead and use these lines to show you what it determined for those scenes. So we'll go ahead and press play. What will happen is it'll go away in the background, use GE core to pre-compute some paths, and then it'll fill them in on the line renderers. And what you'll see is that we get 3 different orbital paths around a central body. So this is useful for people that want to do some offline computation and then maybe show a result in a heads-up display or something without actually running all the evolution in real time. That was kind of quick, but there are more details about all of these things in the documentation. The points just give you a quick overview of what's in here.